Hey Professor Scott, it's Alejandro Zapella, and I will be doing problem 1 of the final exam. So, problem 1 says solve the Cauchy-Euler equation x squared y double prime, let me see here, minus 3xy prime plus 4y equals ln x. Go ahead and start our auxiliary equation. A is 1, so m squared plus b minus a, so 1 minus 3 is 3, m plus c, which is 4, equals 0. Now we'll go ahead and solve for m. So let's think that'll factor into plus actually, I see why I'm having a little bit of trouble factoring, because I didn't quite do it right. I did a minus b, not b minus a. B minus a, b minus a is negative 4. So then that would be minus 2, minus 2 is 0. Negative 2 times negative 2 is 4. Negative 2 plus negative 2, negative 4. Much better. So then m is a repeated root. M equals 2. Which means that we're going to have our repeated roots case. So y sub c is equal to c1 x to 2 plus c2 x to 2 ln x. Now we'll go ahead and find our y sub p. I'll bring it up over here. And as we know, we want y sub p to be u1, y1 plus u2, y2. To find that, we're going to need the Wronskian of y1 and y2, which is going to be, here's y1, so x squared, 2x, y2, so that's going to be a product rule. Well, first just the regular one, and then the product rule, 2x ln x plus the derivative of ln is 1 over x, so that will just be x. And that's going to be 2x cubed ln x plus x cubed minus 2x cubed ln x. So those are going to cancel, and it's just going to be left with x cubed. Now we can go ahead and start solving for the u's. And I know u1 is going to be negative integral of y2, so x squared ln x, times, I need f of x, so I'm going to go back here and get my original equation. Well, yeah, I'm going to go ahead and use Rochelle's theorem. So that's going to be dividing everything by x squared. It's going to give me y double prime minus 3 over x y prime plus 4 over x squared y equals ln x over x squared. Go ahead and put that here. Ln x over x squared. And we're going to divide by the Wronskian, which was x cubed dx. These are going to cancel. So u1 is negative 1 over 3x ln x squared dx. Oh, that was a little bit close. Let me back up a little bit. There you go, so you can see a little bit better. I don't think I can do a u sub here, so I'm going to go ahead and integrate by parts. I'm going to say my u is ln of x squared, and the derivative of that is going to be derivative of the outer opposed to the inner ln x times the derivative of the inner 1 over x. Then my v dv is going to be 1 over x cubed dx. And so v, I should have a dx here. So v is the integral of that, the integral of x to the negative 3. It's going to be x to the negative 2 over negative 2. So now u1 is equal to negative from here, u v negative half x to the negative 2 times ln x squared minus the integral of v du, so 2 ln x 1 over x times negative half x to the negative 2 dx. And let's see where this goes. So u1 is going to be half x to the negative 2 ln x squared minus see, this 2 and this 2 are going to cancel, minus the integral, this and this are going to make over x to the 3 ln x dx. This is bringing me back to what I had the first time. So it's not quite what I had the first time, because I had ln x squared, but I think we're going to have to do another integration by parts, see where it goes. So I'll have u be ln x again, du 1 over x dx, dv 1 over x to the third dx, v negative half x to the negative 2. And now u1 is half, and I get the camera a little bit better, half x to the negative 2 ln x squared minus, here's our second one, so minus uv negative half x to the negative 2 ln x minus the integral of v du negative half x to the negative 2, 1 over x dx. So u1 is half x to the negative 2 ln x squared plus half x to the negative 2 ln x negative, negative, positive, negative, minus the integral. I can pull the half out of there. Half the integral of 1 over x cubed dx, and we know from the other two times what that is already. So half x to the negative 2 ln x squared plus half x to the negative 2 ln x minus half of negative half ln x. So plus quarter x to the negative 2 is u1. Now u2. u2 is the integral of y1, which is, where did it go? Right here. X squared times my function ln x over x squared over the Wronskian dx. These are going to cancel. And I'm going to get u sub 2 is the integral of 1 over x cubed ln x dx. And I know from here what that was. Half, I don't need parentheses, negative half x to the negative 2. Let me fix the camera, that's much better. ln x minus the integral. I guess I can skip that part too, because it's all going to be the same as here. Negative half squared ln x minus that integral, which is going to end up being here. But before I take away this negative, I distribute it in. So negative half x to negative 2 ln x minus a quarter x to the negative 2. So now y is y sub c, so c1 x squared plus c2 x squared ln x plus y sub p, which is u1 times y1. So y1 well, actually, instead of writing it like that, they all have an x to the negative 2 term, so those will just cancel. I guess I'll show the step. Make it nice. Half x to the negative 2 ln x squared plus half x to the negative 2 ln x plus a quarter x to the negative 2. Running out of room. Plus y2 is x squared ln x u sub 2 negative half x to the negative 2 ln x minus a quarter x to the negative 2. So then y is c1 x squared plus c2 x squared ln x plus, distribute this, half ln x squared plus half ln x plus a quarter plus ln x times negative half ln x minus a quarter. And that's it. There's the solution to this Cauchy-Euler equation using a variation of parameters. All right.